these. Okay, so question number 1 says that the person has run 10 kilometers and they want you to convert that into miles. So how do you convert kilometers into miles? The conversion factor.
1 kilometer is 0.62 miles.
1 kilometer per 0.62 miles. Say it again. Okay. 0.62 miles over 1 kilometer. Now what? Multiply. Okay. And your answer is 6.2 kilometers. Cancel. You have miles. All right. The next one. We have someone going at 55 miles per hour. And they want you now to convert this into kilometers per hour. So how do I convert miles into kilometers?
Multiply by
1.61 kilometers
Over 1 mile.
over a mile. Okay. And what's your answer? 88.6. All right, so the next one, we have 5 liters of cardiac output, and they want you to convert liters into quarts. What's your conversion factor?
Multiply that by 1.6 over 3 hours.
How many?
1.6.
1.6?
1.06.
1.05 quarts per liter. So your answer is 5.25 or 5.3?
Yeah.
Okay. The next one, I have 600 milliliters of urinary bladder volume, and they want you to convert this into ounces. How do I convert milliliters into ounces?
1 ounce over 29.57 milliliters.
1 ounce over 29.57
Yes, milliliters.
milliliters. And milliliters are going to cancel, and what's my answer?
20.1.
20.1? Okay. The next one is I have 8 angstroms, and they want to know how many picometers this is. Okay, so now, before we do the conversion, I want to talk to you a minute about angstroms. Because for some interesting reason in physiology, we measure a lot of distances in the body in angstroms. So I want you to kind of have a visual of what an angstrom is, okay? So here you go. An angstrom is to a centimeter, about 1/2 inch. An angstrom is to a centimeter what a centimeter is to a mile. You get that? Let me say it again. An angstrom is to a centimeter what a centimeter is to a mile. That's really tiny. Okay? Angstroms are really, really, really tiny. So when I tell you this blood vessel is only 10 angstroms away from this object, what I'm really telling you is they're like almost touching each other. They're so close. Okay? So we'll talk a lot about angstroms and distances in the human body. All right, so how do I convert angstroms into picometers? Okay, 1 angstrom is equal to 100 picometers. So how would I set that up?
100 picometers over 1 angstrom.
And I know that wasn't in your packet, so you probably Googled that, huh? Smart. So what's your answer? 800?
How would you do that using that original?
Okay,
One-
so
The 10 over.
8 angstroms times
Um,
0.1 nanometers per angstrom, right? So you have 0.8 nanometers. And there are 1,000 picometers per nanometer. So you have 800.
I use the 10, the 10 exponent. Or you
Yeah,
Okay.
well, because I did mine like angstrom to nanometer to meter and then to picometer.
Ow.
Yeah, it's a longer one.
Yeah.
Seriously?
Because like conversion factor.
I like this one. It's a lot faster. But as long as you got the right answer, that's fine. Okay, so the next one is we have a 2,000-pound car, and they want you to convert this into kilograms. So how do I convert pounds into kilograms? Okay, now, tomorrow you are going to have a quiz during lab on stoichiometry. And this is a question I always get. Are you going to give us conversion factors? And the answer is yes and no. Here's a conversion factor you must memorize. 2.2 pounds per kilogram. I'm not giving you that conversion factor. And the reason I want you to memorize that is because this is another thing that you're going to use every single day in the medical field. You are constantly going to convert pounds to kilograms because medicine is in the metric system and we weigh everything in pounds. So you're going to have to convert your patients' pounds to kilograms all the time. So you need to know this now. Okay? So what's 2,000 divided by 2.2? 909. Okay? Next one is I have 15 grams of hemoglobin in 100 milliliters of blood, and they want you to convert that into milligrams per milliliter. So what do I convert first, grams or milliliters? Okay? What do I do?
1,000.
Okay, I'm going to multiply this by 1,000 milligrams per gram. My grams will cancel. And I have 15,000 milligrams in 100 milliliters, right? Now what do? By what? 100, exactly. So I'm going to divide by 100. And what I do on the bottom, I have to do on the top. And so my answer is going to be 150. So instead of being in 100 milliliters, it's just in 1 milliliter. Next one, let's see, we have 120 millimeters of mercury blood pressure. They want you to convert that into pounds per square inch. So how do I convert 120 millimeters of mercury into pounds per square inch?
14% pounds per square inch or 760.
So 120 divided by 760, multiply by 14.7. So now we have a 100-yard dash. How many, what is this, meters do we have? So how do we convert yards to meters?
Multiply by 1 meter over. We need to convert by feet first.
You want to convert it to feet first?
Oh.
Or
Go straight.
you want to go
Here
straight?
is 1.09 yards.
1.09.
1 meter over 1.09 yards? I like that. So it's 100 divided by 1.09?
Mm,
1.74.
91.7? Okay, that looks good. All right, now I have someone who is 7 feet tall. Convert feet to meters. You gonna do 12 inches over a foot?
Yes.
2.54 centimeters over 1 inch.
Okay, so this is 84 inches times 2.54 centimeters per inch. Okay,
I just did 100 centimeters. Or 1 meter under, or over 100 centimeters.
okay, that works. And what was your answer?
2.1336 meters.
Anybody do it differently?
Yes, yeah.
Yeah, how'd you do it?
This we know that is 12 inches over 1 foot multiplied by, we multiplied by 1 meter over 39.4 inches. That's it.
Okay, and what answer did you get?
Same before.
2.1?
Yeah.
Okay, you could do it that way. You could have Googled it and found a direct conversion too. All right, next one. We have 7 microns, and they want to know how many microns is this?
7.
Yeah, 7. So what they're just showing you is that these mean the same thing. Now what's really funny is I'm going to give you a quiz tomorrow, and this quiz is going to take 5 questions from the first part and 5 questions from the second part, and all I'm going to do is change the numbers basically, and inevitably somebody's going to get this one wrong. So I'm going to put like 4 microns equals, and somebody's going to do some weird calculation instead of just putting the number 4 in there. And I always warn people, I always warn my classes, I'm going to give you this question, and never once have I had 100% on this question. It's the strangest thing. It's like somebody is spacing out while I'm saying this somewhere in this room right now. How interesting. All right, so the next one is we have 1 milliliter of urine output per minute, and they want to know how many gallons this is per day. All right, so how do I convert milliliters to gallons? Say it again?
I did minutes today first.
Oh, you did minutes today first? Okay, well, I'll just go with you first. All right, so let's convert minutes today's first. How'd you do it?
I lost it. It's in here somewhere.
No problem.
Maybe it's not. Well, I found out how many minutes were in a day.
Oh, yeah? Okay, so how many?
So 60 minutes in an hour times 24 hours.
Yes?
No.
No? The other way?
Yeah. Wait, no.
Yes?
Yeah. And that's, I don't know how much that is. 1,440.
And what are my units?
Minutes.
Is it?
No.
What are my units? Good. Okay, let me say something to you really quick. Because here's one of the reasons why I think so many students get things wrong on quizzes like this. Is because most of the time in life we're focused on the numbers, and the numbers are really important. But in this type of thing, really what you need to focus on are the units. The numbers are not that important. If you can figure out how to cancel your units, you can plug any number in there any old time and you'd be able to figure out the equation. You have to focus on units, okay? So for instance, in this one, minutes are canceling, hours are canceling, and your unit is day. Okay? That's your unit. So you have to be really aware that your unit is day. Okay? You get lost in there somewhere if you don't keep looking at the units. Okay, so how do I convert milliliters to gallons?
Multiply to 2.264 gallon over a liter.
To what?
0.264.
264?
No, I'm sorry. 0.264. No, that's not.
I just can't hear right. There we go. Is that right?
No, 0.264.
I'll get it.
Yes.
There we go. What are my units?
Well, that's in a liter.
Hmm?
Well, that's in a liter.
0.264, what are my units?
Gallons.
Gallon over 1 liter.
Gallons per liter?
Mm-hmm.
Yes.
Okay.
Oh no, you have to do first a liter over 1,000 and now before that.
Yes?
No. So,
Does it?
yeah.
Look at your units.
Yeah.
Does it cancel?
Yeah.
And so what's your answer? What's the answer to this? Not the answer to the whole thing. The answer to this.
It's
2.64 gallons divided into 1,000.
Yes? 0.264 divided by 1,000, 0.000264 gallons, yes? Okay. So you're going to take these two numbers and divide. So 1440 gallons per day, yes? Okay. And what's your answer?
0.38.
Okay.
I have a question.
Mm-hmm.
Yes, I told you. What if our answer is 0.38 and then you consider the one? Should be 0.4.
This is not chemistry. This is physiology. We're good with 0.4 or 0.38.
Okay.
You do a lot of government work. So it's close. All right, next one. We have, which one is it? 100 milliliters of plasma equals 0.1 liter. You really should know how to do that. Just divide by 1,000, yes? Yeah. Next one, you have a 70-kilogram man. How do I figure out how many pounds he weighs? 2.2. There you go. Pounds per kilogram, and he weighs what, 154? Excellent.
Yeah.
All right, so now we have a 25 degrees Celsius room, which is what we would consider room temperature. How do I convert this to Fahrenheit? 9 over 5,
Yeah, 905.
No,
which is the same as 1.8.
yeah.
25 plus 32 first you have to.
Say it again?
multiply 25, then you have to multiply by 25. 9 over 5 multiplied by close parenthesis 25 plus 32. 25 plus 32.
What do I do with this 25?
Addition that,
No.
multiply now. So those are the solution.
25 multiplied by 9 over 5 multiplied by 25 plus 32?
No, ma'am, we're going to get the Fahrenheit, right?
Yeah, I'm just confused.
I guess she meant that the formula is Fahrenheit is equal to 9 over 5 Celsius plus 32, and then after that.
Okay, but I already wrote down 25, so what do you want me to do with this?
I'm sorry, so the 25 I put it inside already in the parenthesis.
So you want me to erase this? Yeah? Okay.
Sorry for that.
That's okay, I'm just
Sorry about
confused.
that.
Okay,
Sorry.
so
I
this
just
is right?
I just dropped.
No,
No,
drop the parentheses.
Drop the parentheses
Yeah.
and do that. And we're good? Yeah? Okay, I don't know, you tell me. I'm just listening to what you say. What does this number get me?
77.
77. Okay. All right, next one is 98.6. How do I convert that to Celsius? Subtract 32.
And then multiply that whole thing by 5 over 9. Is 22.78. What did they eat?
Is that correct?
yes.
Yes. All right, next one. We have a very strong person who is lifting 500 feet, or 500 pounds, 6 feet off the ground. How much work has he performed? Okay, now, whenever you have units next to each other like this, that means that the numbers that go with those units are multiplied. So he is moving at 6 feet off the ground. It's 500 pounds. So you have 3,000 foot-pounds. If the numbers were on top of each other, or excuse me, if the units were on top of each other, you would divide. Okay? So now the next question is, how do you convert 3,000 foot-pounds into kilogram meters?
1 kilogram meter over 7.23 foot-pounds.
Okay? 1 kilogram meter over 7.23 foot-pounds. So what's 3,000 divided by 7.23?
414.9.
414.9. Very good. Okay, so now the next question is, how many calories of energy did he use to produce this work? So you can either use the 3,000 foot-pounds or the 414 kilogram meters to figure out calories. What do you prefer to use? 3,000 foot-pounds, okay, probably easiest. So how do I convert this into calories?
Multiply it by 1,000 over
1,000 calories over what?
3.86. 3 point
And what's my answer?
97.
972 calories? Yep. Okay, so now, if he performs this feat 11 times in 1 minute, what is his horsepower? Okay, so I would recommend the 3,000 foot-pounds times 11 times per minute, and that gives you 33,000 foot-pounds per minute. Oh, what's the horsepower of that?
Yeah,
It's 1.
1.
And 1 horsepower is exactly how many watts? 7 what? 746. So 1 horsepower equals 746 watts of energy. If you could keep that up, you could generate a few light bulbs. Number 3, a physician has orders. He has a 0.35 milligram per kilogram body weight drug dosage for a 215-pound patient to control the patient's blood sugar levels. How large is each dose? Kind of sort of important. How do I figure out the dosage?
You have to get his weight in kilograms first.
Excellent. So he's 215 pounds, right? And I want to convert that to kilograms. So what do I do? 2.2 pounds per kilogram, yes? So 215 divided by 2.2 is what?
97.7.
97.7 kilograms. Okay, excellent so far. Now what?
You multiply it by the orders.
Okay, so the orders are 0.35 milligrams per kilogram, yes? And so our kilograms are going to cancel. And what is 97.7 multiplied by 0.35?
34.1.
30 what?
34.1.
34.1 milligrams per dose. All right, next question. How many grams of glucose would you need to make 500 milliliters of an 8% solution? Okay, so here's that next thing you have to memorize. The percent solution is the grams, or the weight of something, divided by the volume in milliliters times 100. So this is an 8% solution that we're starting with. And anytime they give you a number like this, just assume that this is the same thing as 8 grams in 100 milliliters. And they want you to make 500 milliliters. Well, if it's 8 grams in 100 milliliters, then you just multiply it by 5, and you have 40 grams in 500 milliliters. Okay, so, Brandon, right? Okay, so Brandon, I'm going to pick on you. So if I actually asked you to make this solution, and let's say, what did they say what the solution was? Was it glucose? Yeah, so it's glucose. So I want you to make an 8% solution. I want you to make 500 milliliters of this 8% solution. In order for you to make it, what supplies do I need to get you? Well, what do you think? You're going to make this for me, so what do you think you need?
Glucose and
That's a good start. What else? So you need, I'm going to bring a jug of glucose out for you, set it on your table. Now what else do you need?
something to measure.
Something to measure, okay? How are you going to measure your glucose? What are you going to need to measure it? You need a beaker. Okay, what else? What else are you going to need to measure your glucose? No, not that. A scale. Okay, a scale would be good. What else does he need? So we got a bucket of glucose, we got a scale, we got a beaker. What else does he need? Huh?
Water?
Some water. Okay, we can have some water, but he's still got to measure the glucose. So if I've got like a bucket of glucose here and a scale here, how do I measure the glucose? What do I do?
You have to measure your container you're going to hold glucose in on your scale first.
Okay, so I probably need like one of those little weigh boats.
Uh-huh.
Okay, so I need a weigh boat. I'm going to zero it out in my scale. Then what? How about if I scoop some glucose in there? Right? Okay. Until I get 40 grams of it, right? So I'm going to weigh out 40 grams of glucose in my little weigh boat, right? And then Brandon already said I need a beaker. Okay? And somebody else said I need water. Okay, so I can get some water in like a graduated cylinder, right? How much water do I need? 500 milliliters. Okay, so I better make sure my graduated cylinder is 500 milliliters, and I'm going to put some water in there. So now I've got my glucose in my little weigh boat thing here. Okay, and I've got my beaker. Now what? So I weighed out my 40 grams of glucose. I have my 500 milliliters of water. I got my beaker. Now what? Put my glucose in? Put that in first? Okay, so I should put my glucose in first. Okay, now what? Say it again?
Fill it up with the solution until you get the 500.
Until I get to 500 where? In my beaker?
Yeah.
Okay, so I'm going to pour the water in only until I get to the 500 milliliter mark. Yes? Sure?
No, you have to pour the 500 milliliters over there, the whole thing.
I gotta pour the whole thing in here?
Yeah. It doesn't matter if it's 500 ml, as long as you have the 500 ml, that's the whole thing.
Say again?
It's still water, right?
It's water, yeah. So, okay, so we've got two camps now. Uh-oh. Because like if I'm making an IV of this glucose for my patient, which camp is correct? Should I, the right one, should I only fill it up to the 500 milliliter mark, or should I pour all 500 mils in? Because you know, if I put my glucose in first, it's going to come up to a little bit above 500 mils, right?
Isn't the whole solution supposed to be 500 mils, so that would be much?
Oh no, are you asking me or telling me?
I don't have any idea.
So probably you need to put the 40 grams of glucose first,
Right? I put that in first.
and then
Add.
whatever you need
The water.
to make the 500.
Oh, you're in their camp. Only bring it up to 500. Okay? Well, what about this? Hold on now. Should I put the water in first and then the glucose after?
Yeah.
Yeah, that's what it is.
Oh, now there's a third camp. Okay, whose camp is correct? Because in actuality, this is really important, especially if you're making certain solutions for an IV. And like glucose may not be that big of a deal, but if you were making certain salt solutions, it could be a very big deal. What you put in first and how much you do it, and you're absolutely correct. You are always going to put the solute, the smallest amount in first, and then The total amount is 500 mils. So you only put in enough water to go up to the 500 milliliter mark. You don't want to go above that. And then, of course, stir. And then you can give this to your patient. And you know, it's all well and good that we can learn how to calculate all this stuff, but you really need to know how to mix it too. Because if anything ever happened, if there's any kind of disaster or catastrophe, earthquake, whatever, you might be the ones mixing IVs. And by the way, when you make mine, make sure it has doubly distilled deionized water. Super pure for me, okay? Everybody else, I don't care. All right, just for me, when you make mine, make sure it's nice and pure, okay? Exactly, get your water from China, it's really good, right? All right, number 2. What is the percent concentration of 6 grams of sodium chloride dissolved in 1 liter of solution? So knowing that equation there, your percent solution, how would you figure this out?
I did 6.0 grams
Okay, 6 grams.
over 1,000 milliliters.
Because remember, it's got to be in milliliters, not liter. Okay?
Times 100.
Times 100. Perfect. And your percent is?
0.6.
0.6. That's excellent. You gonna keep her on your team now? Yeah. All right, question number 3. How many grams of potassium chloride would you need to make 250 milliliters of a 0.5 molar solution? All right, now, before we get started on this, here's what I typically see with students. They get a question like this, and they look at this, and they become like a deer in the headlights. It's like, holy crap, where do I start with all of this? So I'm going to give you some steps on how to make this easier. And step number 1 is don't just stare at it and hope that angels come down and teach you how to do this, okay? Step number 1, put everything down on the paper. All the numbers, just write them down. Okay, so let's write some numbers down here. I'm going to erase this one. So, one of the numbers, we have 250 milliliters, and we have 0.5 molar. Now, there's a hidden number here. It is potassium chloride. So one of the other numbers, if you go back, is the molecular weight. And for potassium chloride, the molecular weight is 74 grams per mole. Okay, so we have all our numbers down. All right, now, next question is, what unit are we looking for?
Grams.
Grams, super important. You want to put that somewhere so you know you're looking for grams. Now remember how I told you that students get all caught up in the numbers? So here's what we're going to do. Forget the numbers. We'll plug them in later. Let's just solve the units. Now, look at this. We've got grams, right? So somehow we can put these units together to just have grams in the end. Now there is one problem. See this big one right here? You got to break it down into the smaller units. And molar is the same thing as moles per liter. Okay? So now watch. I have milliliters, I have grams per mole, and I have moles per liter. Can you figure out a way to manipulate those units so that I just have grams?
You want to change your milliliters to
Oh, liters per milliliter.
How about if I do it this way? This will be
liters? I do it
easier.
backwards.
I could just do it like this. This is 1,000 milliliters, right? How would you set those units up to just get grams?
Multiply.
Just multiply. Check this out. Milliliters cancel. Moles cancel. You have grams. You just solved your equation. So now let's just go back and plug all the numbers in. Remember, this is 74 grams per mole, and this was 0.5 moles per liter, and we had 250 milliliters. All you do is, yep, 9.2. So your answer is 9.2 grams, yes? That actually wasn't so hard, huh?
Yeah, but you know what, it's not gonna remember that.
Oh, well, we're going to practice it again. Okay, so the next one. What is your percent, oh no, I'm sorry, number 4, right? What is the molar concentration of a 9% solution of glucose? Okay, so I want you right now, solve it. Work on it. Step number 1, write everything down. All your numbers, go, try to solve it. All right, let's see what you got. Here we go. So we have a 9% solution, okay? And we know it's glucose, so this is 180 grams per mole. And they want to know what the molar concentration is, which is the same thing as moles per liter. This is what we're trying to find. Okay? So did you write that all down? Did you get all that written down? Okay. Now, once you write all your numbers down and you know what you're looking for, like moles per liter, you have to look to see if there are any numbers, any units that can be broken down into simpler form. So 9% is the same thing as 9 grams in 100 milliliters.
I got that part right.
Yay! Okay, so look, we're looking for moles per liter. That's what we're looking for. Okay? So here are the units we have. We have grams per mole. That's these units here. And we have grams per 100 milliliters. And we need moles per liter. How are you going to use these units? No numbers needed. How are you going to set these units up to get moles per liter?
We're gonna change milliliters to liters.
Okay, you want to do that first? So we can multiply this by 10. Okay, so we'll do it on the top and the bottom. So this is grams per liter now. Okay, now we have grams per liter, we have grams per mole. How do we get moles per liter? Yes? We take these two and just turn this one upside down. So here we go. This one is 9 grams per 100 milliliters. We're going to times this by 10. That's what we did right here. And so we have 90 grams per liter. And then we're going to multiply this by 1 mole over 180 grams. Because that's this number here. We turned it upside down. What's 90 divided by 180? 0.5. So your answer is 0.5. You have 0.5 moles per liter. Okay, the next one, number 5. What is the percent concentration of a 0.3 molar solution of calcium chloride? Go, you have 2 minutes, write it down, see if you can figure it out. do it on your own, see what you can do. All right, let's go over this, see what you got. Okay, so we have a 0.3 molar solution, and it's calcium chloride. So what's the molecular weight for this? 110. So 110 grams per mole. And they want to know what is the percentage, which is the same thing as grams in 100 milliliters. She not back there?
She is. She just doesn't have the form yet. I'll get it from her tomorrow.
Okay, no problem. You want to come and play stoichiometry with us? No.
No, they can have all that.
All right. Okay. She is. She's not. Yeah. So, 0.3 molar is the same thing as 0.3 moles per liter. And we have 110 grams per mole. And we want to find grams in 100 milliliters. So we have 0.3, well, we don't need the 0.3, do we? Let's get rid of that. We have mole per 1,000 milliliters. And we have grams per mole. So how do we get to grams per milliliter? Yeah. So moles will cancel. We have grams in 1,000 milliliters. Okay, so watch. If we have 0.3 moles in 1,000 milliliters times 110 grams per mole, okay, our moles will cancel. And we end up with 33 grams in 1,000 milliliters times 100, and that will give you your percentage. Because it's grams divided by milliliters times 100. And so your answer should be 3.3. Okay, let's try another one. Except this time I'm going to make it up. So listen close. I want you to tell me what the percent solution is for a 0.5 molar solution of sodium chloride. What is the percent solution of a 0.5 molar solution of sodium chloride? Go, you have 2 minutes. Okay, so we have a 0.5 molar solution of sodium chloride. What's its molecular weight? 58.5 grams per mole. And we want to find percent. So how do I set this up?
Same way you did the last one, you just changed the numbers.
Yes, very good. So how do I set it up? 0.5 moles per 1,000 milliliters
58.5 grams of
times 58.5 grams per mole. Moles will cancel. So what is 58.5 times 0.5? 29.25.
grams.
And that's going to be grams over 1,000 milliliters times 100. And that should be your percentage.
Where do you get the 100 from?
Thank you. That's what I
Ah,
was just
because
I mean,
thinking.
I have it, I just don't know why.
Because anytime you're going to convert something to percent, you always multiply by 100. Okay, let's try the next question. concentration of 0.15 molar. How many grams per liter is this? Go, figure it out. It's question number 6 on your technical. Okay, so what is the atomic weight of sodium ions? 23 grams per mole. And then we have a 0.15 molar solution, which is the same as 0.15 moles per liter. And they're asking for grams per liter. This is what we have to find. So we have grams per mole, and we have moles per liter. How can we set this up to get grams per liter? Multiply. So you can put your number in here, 23.15.
3.45.
Say it again.
3.45.
There you go. The next one, what is the osmolar concentration of an 11.7% solution of sodium chloride? Okay, so osmolar equals the number of ions in solution times the molarity. So you have to find molarity first in order to find osmolarity. So this question says that we have an 11.7% solution of sodium chloride, which is 58.5 grams per mole. And they want us to find osmolarity. So we have to find molarity first, which is moles per liter. This is what we're looking for. So, any changes you'd make to any of this that I wrote down? What would you do next? What would you change the percentage to? 11.7% is the same thing as 11.7 grams over 100 milliliters. So I have 11.7 grams in 100 milliliters, and I have 58.5 grams per mole. And I need moles per liter. What would you do next?
You would switch the 58.5 grams per mole, switch the conversion where the 58.5 is the denominator.
Okay. What would that do for me? Okay, so I'd multiply these.
Yes.
Yeah.
So grams will cancel. And I have 11.7 divided by 58.5. You'd multiply right now? Because I wouldn't.
You have to convert milliliters to liters.
Okay.
So you would multiply
By what?
by
10. So I have 117 grams liter, right? Times moles over 58.5 grams, which would give me what? What's 117 divided by 58.5? 2. This is 2 moles per liter, which is the same thing as a 2 molar solution. Where molarity is 2. However, they want you to find osmolarity, and we are using sodium chloride. And if you put sodium chloride into solution, it falls apart into sodium ions and chloride ions. So the number of ions is 2. So we take our molarity and multiply by that 2 ions, and our osmolarity is 4. Okay, so here's another one I want you to work on. I want you to tell me what the osmolarity is of a 22% solution of calcium chloride. What is the osmolarity of a 22% solution of calcium chloride? Okay, so we're doing calcium chloride, and we have 22%. What else do I need to know?
Calcium chloride is 110 grams per mole.
Excellent. 110 grams per mole. What else do I need to know? What else should I write down?
The number of ions.
Okay, so it's going to be 3 ions. Okay. What else should I write down?
Percentage.
I already have percentage.
So you
22.
know,
Oh, you want me to change it? Okay. What do I change it to?
22 grams over 100 milliliters.
22 grams over 100 milliliters. Okay. What else do I need to write down? I'm missing one thing before I get started. What am I looking for?
Moles over liters.
Osmolarity.
Okay, we want osmolarity, but we have to find molarity first. Okay, I got to keep my eye on what I'm looking for. All right, so now I've got 22 grams in 100 milliliters. I have 110 grams per mole. How do I set this up?
I would change the 22 grams into over 100 milliliters to 220 grams per liter.
So I'll multiply by 10. So you have 220 grams per liter. Okay, now what? What do I do next?
Moles over 110 grams.
Okay, so I'm going to multiply this by my moles over 110 grams. And my grams will cancel, so I'll get moles per liter, which is what I was looking for. And my moles per liter is what? 2. And I have 3 ions, so I multiply by my 3 ions. And I have an osmolarity of 6. Okay, let's try the next one. It says, excuse me, I have a 0.9% solution of sodium chloride, which is isotonic to mammalian cells. What is my molar concentration? Okay, so let's go over this. We have a 0.9% solution of sodium chloride. What else do I need to write down? Okay, 58.5 grams per mole. Okay, what else? What else do I need to write down?
What we're looking for.
Okay, which is
Molar concentration.
Okay, so I need moles per liter. This is what I'm looking for. Okay, what else do I need to write down?
9 grams per liter.
Okay, so this is 0.9 grams in 100 milliliters, yes? Okay? All right, do I need to write anything else down, or am I ready to go? Okay, so I'm going to do what? Times by 10. And now I have 9 grams per liter. Excellent. Now what? I have a feeling you're starting to get this. So, what is 9 divided by 58.5? Say it again? Okay. 0.15 moles per liter, or a 0.15 molar solution. If I wanted to figure osmolarity, what would I do? Two ions.